Britain invented the tank. In September 1916, on the muddy fields of the Somme, the world saw for the first time an armored machine rolling across no man's land, and the course of warfare changed forever. Britain gave the tank to history, but here is what history rarely tells you. For the next 3 decades, Britain also produced some of the most dangerous, unreliable, and genuinely hated armored vehicles ever inflicted on the men who had to crew them. Not hated by the enemy, hated by their own soldiers. Men who climbed inside these machines every morning, knowing that the vehicle itself might kill them before the enemy ever had a chance. This is the story of Britain's mechanical nightmares, the tanks that roasted, broke down, trapped, and in some cases killed the crews who served in them, told in the order they appeared, from the very first day a British tank went to war, all the way to the final months of the Second World War. Mark I, the Iron Oven. The Mark I tank entered battle on September 15, 1916, at the Battle of Flers-Courcelette. Of the 49 vehicles earmarked to take part, only 32 made it to the start line, and of those, just 18 actually went into action. The rest broke down, ditched in shell holes, or suffered mechanical failure before firing a single shot. That mechanical failure rate before contact with the enemy was not bad luck. It was a warning that nobody heeded. Inside the Mark I, 8 men shared an undivided hull space with a fully exposed engine. There was no firewall, no separation, no barrier of any kind between the crew and the machinery. Internal temperatures regularly reached 50 degrees Celsius, and entire crews lost consciousness inside the vehicle from the heat alone. The atmosphere was a toxic mixture of carbon monoxide from the engine, fuel and oil vapors, and cordite fumes every time the guns fired. Crews were issued leather and chainmail face masks to protect against bullet splash, the molten metal fragments that sprayed off the interior hull when rounds struck the outside. But most men refused to wear them because the masks blocked the already catastrophic visibility. Communication between the driver and the gearsman was impossible over the deafening noise, so the driver signaled by hitting the engine block with a heavy spanner and hoping someone understood. The tank's top speed never exceeded 6 kilometers per hour, meaning the infantry the Mark I was supposed to support frequently outpaced it across the battlefield on foot. Light tank. Mark VI. The reconnaissance coffin. Moving forward in time, but not forward in quality, the light tank Mark VI arrived in the mid-1930s as the primary armored vehicle of the entire British Expeditionary Force. When the Battle of France began in May 1940, over 257 of the 1st Armored Division's tanks were Mark VIs and VIIs. The armor ranged from just 4 millimeters to a maximum of 14 millimeters, thin enough to be pierced by heavy machine gun fire, let alone any dedicated anti-tank weapon. Crews were armed exclusively with machine guns, a .303 Vickers and a .50 Vickers, giving them no ability whatsoever to engage German Panzer IIs or Panzer 38s that outgunned and outarmored them in every single engagement. The commander was also required to double as the radio operator, leaving him unable to simultaneously direct the tank, communicate with other vehicles, and observe the battlefield, a fatal workload in combat conditions. Of approximately 340 Mark VI light tanks sent to France, only 6 were evacuated at Dunkirk. 6. The rest were abandoned on French soil, leaving Britain almost entirely without armored vehicles for home defense during the summer of 1940. Matilda I/A11, the machine gun coffin. The next vehicle on our list arrived even before the Mark VI, but its failures deserve their own chapter. The Matilda I, designated A11, was designed on a budget so restricted that a single machine gun was the only weapon fitted, making it, by later historians, unanimous assessment, obsolete before it ever entered service. The driver's compartment was so cramped that ergonomic problems were identified in the very prototype, but officially deemed impossible to correct without redesigning the hull from scratch, so they were simply left in. Track pin failures were so frequent during initial trials that the suspension required a full redesign in April 1937, just months after production had begun. The tank's sole armament, a .303 Vickers machine gun, was completely useless against German armor. Crews had no means of engaging enemy tanks under any circumstances. General Hugh Ells nicknamed it Matilda due to what he called its duck-like waddle, a name crews found grimly appropriate given how helpless it was in any real combat situation. Matilda II/A-12. The Queen who couldn't keep up its successor, the Matilda II or A-12, looked more impressive on paper. Heavily armored and initially effective in North Africa, it earned a reputation early in the Ashanti Desert War. But crews learned quickly what living with it really meant. The engine was assembled from two civilian AEC bus engines, units originally designed for London public transport, linked to a single crankshaft and producing under 200 horsepower to move a 27-ton tank. The twin-engine arrangement doubled every maintenance task: 2 coolant systems, 2 lubrication systems, 2 complete sets of components to service under desert heat or Arctic mud. Top speed on road was a barely credible 24 kilometers per hour, dropping to just 9.7 kilometers per hour across North African terrain. During Operation Battle Axe on June 15 to 17, 1941, 64 Matilda IIs were lost in a single operation when Rommel positioned 88mm anti-aircraft guns in an anti-tank role against tanks too slow to maneuver clear. Soviet crews who received over 1,000 Matildas under Lend-Lease reported that snow and mud constantly clogged the drivetrain, and the turret ring was physically too small to ever accept a gun larger than the 2-pounder, meaning the tank could never be upgunned. Crews watched it become obsolete with no possible remedy available. Despite being clearly outclassed by 1942, production continued until August 1943, building nearly 3,000 units of a design that could not be improved. Valentine, the claustrophobic workhorse. The Valentine, officially the infantry tank Mark III, was more reliable than most of its contemporaries, and its crews acknowledged that much. But reliable does not mean comfortable, and it certainly does not mean safe. The War Office's primary objection to the Valentine's original design was that its turret was so small it could accommodate only 2 crewmen, going directly against doctrine requiring a gunner, loader, and commander in every gun tank. In the 2-man turret configuration, the commander was simultaneously responsible for commanding the tank, loading the gun, operating the coaxial machine gun, and managing the radio, an impossible workload in combat. The 2-pounder gun was never issued high-explosive shells, making the tank useless for infantry support, the very role it was designed for. When it was upgunned to the 6-pounder to improve anti-tank capability, the loader's position had to be eliminated again, returning to 2 men and restoring the same impossible burden on the commander. Despite all of this, 8,275 Valentines were built, more than any other British tank design, a number that reflected not the vehicle's quality, but the Army's desperate need for anything that moved. A 13 Covenanter, the tank that roasted its crew. Now we arrive at perhaps the most notorious name on this entire list. The Covenanter, designated A-13 Mark III, was designed not by tank engineers, but by the London, Midland, and Scottish Railway Company, a firm with no prior experience building combat vehicles of any kind. The British War Office ordered 100 Covenanters before a single prototype had been built, tested, or evaluated. The Flat Meadows engine was so low profile that there was physically no space in the engine compartment for a radiator, so designers routed coolant pipes the full length of the hull directly through the crew's fighting compartment. During trials, coolant temperatures reached 177 degrees Celsius, nearly double the safe operating limit, after just 2.5 hours of operation. Crews of the 22nd Armored Brigade filed formal complaints documenting engine overheating, transmission overheating, and unbearable working temperatures inside the fighting space. A total of 1,771 Covenanters were built between 1939 and January 1943, representing at their peak roughly a quarter of Britain's entire operational tank strength, and not a single one was ever cleared for overseas deployment. Canadian crews reportedly buried their Covenanters rather than return them, a judgment that historians have since described as one of the greatest procurement disasters in British military history. A 15 Crusader. Desert. Breakdown. The Crusader, a 15, learned nothing from the Covenanters' lessons. Rushed into production in mid-1940 and shipped to Egypt before adequate development trials had been completed. The Crusader's first major engagement, Operation Battle Axe in June 1941, saw more tanks lost to mechanical failure than to enemy action. The two most common failures were a radiator fan drive that wore out faster than it could be replaced in the field, and water pump seals that dissolved almost immediately in the North African sand. Making matters worse, Crusaders shipped to Egypt were routinely started by Liverpool dock workers maneuvering tanks into loading positions, running the engines without oil and causing internal damage before crews ever received their vehicles. The Crusader's 2-pounder gun was never issued high-explosive ammunition, leaving crews completely unable to engage the dug-in anti-tank screens the Afrika Korps deliberately used to lure British armor into killing grounds. Upgrading the Crusader 3 to the 6-pounder in 1942 required reducing the turret crew from 3 men to 2, forcing the tank commander to also act as loader, an impossible burden in combat. By 1943, British crews in North Africa welcomed the American Sherman as a deliverance despite its own shortcomings, having completely lost faith in the Crusader after 2 years of chronic breakdown. A 22 Churchill, the mechanical abortion. The Churchill, a 22, is a complicated case. It began as a disaster and eventually redeemed itself, but the men who served in the early versions experienced something closer to the disaster than the redemption. Vauxhall Motors was handed the A-22 specification in June 1940 and ordered to put it into production within exactly 1 year, a timeline that made thorough testing or quality control entirely impossible. The first production Churchills were delivered in June 1941 with a supplementary leaflet inside the user handbook listing known faults and suggested workarounds while corrections were still being made by the factory. A Soviet technical assessment concluded the Churchill was unrefined, both from a design and production standpoint, and would require frequent repairs and module replacements in field conditions. Some 1,000 first production Churchills required factory-level revision programs carried out by Vauxhall technicians visiting units in the field. At the Dieppe raid on August 19, 1942, the Churchill's first major combat test, not a single one of the 29 tanks that went ashore was recovered, and the entire Calgary Regiment's tank crews that landed were killed or captured. The Churchill eventually proved itself in Tunisia and Italy, earning genuine crew respect in its later marks. but only after years of forced improvement that should never have been necessary. A 24 Cavalier, the Crusader's cursed son, and then there is the Cavalier, a 24, which takes the Churchill's story and removes the redemption entirely. The Cavalier was designed by Nuffield, Mechanization, using the same Liberty engine and Wilson steering directly inherited from the Crusader, guaranteeing it would reproduce the same lubrication and cooling failures that had condemned its predecessor. An order for 500 vehicles was placed before the prototype was completed or tested, repeating the identical bureaucratic error that had created the Covenanter disaster 3 years before. First trials in March 1942 immediately identified the Cavalier as unsatisfactory. Only 503 were ultimately built before the design was abandoned, and it never entered frontline service in any combat role whatsoever, used exclusively for training and representing a near-total waste of manufacturing capacity at a critical moment in the war. A 27L Centaur, the stopgap that stopped the Centaur, a 27L, followed the Cavalier and made essentially the same mistake with a different nameplate. Leyland Motors backed out of its commitment to produce the superior Rolls-Royce Meteor engine and chose, instead, to continue building the underpowered Liberty engine it already knew. The Liberty produced only 395 horsepower in the Centaur versus 600 in the near-identical Cromwell, making the two tanks look the same from outside, but perform completely differently in the field. In August 1943, reliability trials covering 2,300 miles, the Sherman came first, the Cromwell came second, and the Centaur arrived at each night's camp hours after the other tanks. A further November 1943 trial confirmed the Centaur's basic problem was the Liberty engine being fundamentally underpowered for the vehicle's weight. Despite this confirmed failure, approximately 1,800 Centaurs were produced across 8 separate industrial groups, almost all unsuitable for frontline service. The only Centaur variant to see combat was the close support version firing from landing craft on D-Day, June 6, 1944. Never used as a conventional battle tank at all. A 30 Challenger, too tall to live. Moving to 1943, the Challenger, a 30, was created to solve a genuine problem, which was mounting the powerful 17-pounder anti-tank gun in a vehicle that could keep up with the Cromwell. It solved that problem and created several new ones. The gun's size forced engineers to design an entirely new, much taller turret that made the Challenger immediately recognizable on the battlefield and, crucially, immediately identifiable as a priority target by German anti-tank gunners who knew exactly what it was. At 2.77 meters in height, the Challenger was significantly taller than the Cromwell it was based on, stripping away the low-profile advantage that had been one of the Cromwell's genuine assets. The elongated hull required to support the new turret created structural stress that contributed to chronic reliability problems throughout its service life. Only 200 Challengers were ultimately built, a number so small that logistical support and spare parts became a permanent operational headache. By the time it reached units in Normandy in 1944, the Sherman Firefly had already proven more practical, cheaper, and faster to produce, making the Challenger redundant almost immediately after its arrival. A 34 Comet, so close, so late. And finally, we reach a vehicle that is not hated in the same sense as the others, but whose story is perhaps the most bittersweet of all. The Comet, a 34, was genuinely good. Crews who finally received it in early 1945 described it as the first British tank they had served in that felt competitive against German armor. Better gun, better protection, better crew layout. It succeeded on almost every technical measure. Production delays meant only the 11th Armored Division was fully equipped with Comets before the war in Europe ended in May 1945. The rest of the British Army fought to the end in Cromwell's and Sherman's, while the vehicle that could have made a difference sat waiting in British factories. The 77mm gun's ammunition was incompatible with every other British vehicle, creating a fragile and dedicated supply chain for the handful of units that had it. The Comet arrived 4 years and thousands of casualties too late, and in doing so became the perfect final symbol of everything that had gone wrong before it. The institutional reckoning. Britain invented the tank in 1916 and then spent the next 3 decades proving that invention is not the same as mastery. The root cause was structural. Throughout the 1930s, rearmament budgets were directed overwhelmingly at the RAF and Royal Navy, leaving the Army to develop armored vehicles on near-starvation funding with inadequate engineering oversight and disastrous procurement timelines. Orders placed before designs were finished, designs finalized before testing was done, problems identified in trials and then ignored because production had already begun. The same mistakes, repeated from the Covenanter to the Cavalier, from the Centaur to the Challenger, across a decade of war. Post-war, analysis identified that the single greatest cause of avoidable British tank crew casualties was not enemy action, but mechanical unreliability. Vehicles that broke down, overheated, or stranded their crews in combat situations. The men who climbed into these machines every morning knew what they were getting into. They filed the reports. They sent the complaints. They documented every failure. And then they climbed back in and did it again. The Centurion, which finally delivered what British crews had needed since 1939, entered service in May 1945, the last month of the war in Europe, arriving just in time to miss every battle it had been built to fight.